Hello students, in the last class we were discussing about some of the important concepts relating to the classification of elements and periodicity in properties. In that already we have seen how far the periodic table has been established from day to day, their experimental explanations, and as the number of elements increased by the discovery of different scientists, so there was a particular arrangement of elements in groups as well as periods that will call it is in the form of rows and columns. So that is the complete picture about the periodic table. So previously they assumed some of the concepts which are related on the basis of atomic masses. The elements are arranged on the atomic masses. So those were Dobrinian law of Trad also we have learned, Newland law of octave we have learned. Along with that, we have also learned that is a Mendeleev periodic law. At last, we have come to the conclusion that is a modern periodic law, and a modern periodic table is worldwide or universally acceptable periodic table. So along with that, we have also studied the nomenclature of the elements with atomic number greater than 100. So I have already explained the digit term, name and abbreviation, and I have also given some of the examples to solve, and I have explained how to nomenclature of elements with the atomic number greater than 100. So that is 0 is called as nil, 1 is called as un, 2 is for bi, 3 for tri, 4 for quad, 5 for pent, 6 for hex, and 7 for sept, 8 for oct, and 9 for n. So we have seen many examples related to 102 is called as un nil bium, right? So at the end, so we must add the word IUM, and in the symbolical representation we can mention it as UNB like this. So even in the work also we have given some of the examples, and some of you have already given back the answers for the nomenclature of elements in the atomic number greater than 100. That's all we have learned in the previous class, but in today's class we'll go with the extended part of the classification of elements and their periodicity. So that is a periodic table. We have a brief idea regarding to the periodic table. So in that, the first important part is the periodic table consists of different blocks. So generally if you see the periodic table, so that periodic table consists of 4 important blocks. So one is considered as S block, second one is P block, third one is D block, and fourth one is S block. Therefore, so the 4 important, which means the periodic table mainly, that is modern periodic table, so which means the atoms are arranged on the basis of atomic number, because according to modern periodic law, so they says that the periodic properties of the element are completely dependent on the atomic number but not on the atomic mass. Therefore the elements are arranged in the form of rows as well as columns in case of periodic table according to modern periodic law, and it is worldwide accepted. Even today the same periodic table used in case of chemistry, right? So therefore further if you divide that periodic table, it consists of mainly 4 blocks. One is X block, P block, D block, as well as F block. The S and P block elements are generally called as main group elements, or there is another name for both S and P block elements. Those are called as the representative elements, right? So this can be asked for 1 mark. So most of the time it is repeated in the annual examination. So define representative element, or what are representative elements. Always remember the S block and P block elements, so which are generally called as the main group. These both are main group in the periodic table, and these elements are also called as, or these are also named in the form of representative elements, right? So remember, S and P block are very important. All the 4 blocks are very important, but the main groups in case of main group elements are represented in the form of S block as well as P block, and there is another name for that, that is representative elements in the periodic table. It can be asked for 1 mark. So further, if you go on studying the general information regarding to the different blocks, so S block, it generally consists of group 1 so and group 2, right? So there are 2 groups in the S block, so that is group 1 as well as group 2, right? So group 1 elements are called as alkali metals, and group 2 elements are generally called as alkaline earth metals. Remember, there are 2 groups in the S block. So one is group 1, so which is termed as alkali metal, and group 2 is termed as alkaline earth metal, right? So which respectively have the electronic configuration, that is general electronic configuration of NS1 for group 1 and NS2 for group 2, and outermost electronic configuration. If you go for the outermost electronic configuration in case of S block, so generally S block is divided into 2 groups. One is group 1, and it is named as alkali metals, and group 2 is alkaline earth metals, which respectively have the electronic configuration, that is outermost electronic configuration, that is ns1 and ns2, right? So this is a brief information regarding to the s block element. And the second block in case of periodic table is a p block, and they belong to group 13 to group 18, right? So whatever the elements which comes under group 13 to group 18, so these are generally considered as a p block elements, which means there are the elements which are present in case of group 13 to group 18. So these elements are generally comes under the p block elements. And outermost electronic configuration in case of p block elements is ns2, so that is np1 to 6, right? So ns2, because s block is completely filled, so therefore we have to show that the s block is completely filled. Further, the electron will jump to the p block, that is p orbital, so therefore it is ns2 completely filled, and further we'll write the np1 to 6, because maximum, so it can hold 6 electron, minimum it can hold 1 electron in its outermost orbit, so therefore np1 to 6. Since we have seen the different shape of the orbitals in the previous chapter, so there also we have seen the arrangement of electrons and stability of the electrons. So in that we have seen the p orbitals are 3, px, py, pz. Since there are 3 p orbitals, so maximum it can hold 6 electrons. So therefore the electronic configuration, what happens, it will become so ns2 np1 to 6, right? So here I will do some rough work. So that is s block. In s block, what happens, so there are the electronic configuration ns2, right? So minimum 1, maximum 2. So because it is having only one orbital, it can hold 2 electron, maximum 2 electron, right? So therefore in case of p block, what happens, right? So that is ns2, so np1 to 6, so minimum 1, maximum 6, right? So ns is already completely filled, so therefore whenever you go for the p orbitals, the p orbitals are 3, right? So minimum it can hold 1 electron and maximum it can hold 6 electrons. So therefore the electronic configuration in case of outermost orbit is considered as ns2 np1 to 6, right? So further if you go for d block, right, so we have to mention again ns2, so np6, and it is n into d 1 to 10, right? So because minimum electron which is present in the d orbital is 1 and maximum 10. Since there are 5 d orbitals, we have seen that there are 5 d orbitals, so therefore s is completely filled and p is also completely filled, and there are 5 orbitals in case of d. So therefore the total number of electrons maximum it can hold 10 electrons. So therefore its electronic configuration becomes ns2 np6 nd 1 to 10, like this, right? So you can write the electronic configuration of all the elements which are present in s block, p block, t block, as well as f block, right? So like this, it can hold maximum 14 electrons, right? So that we'll see further. So here in case of a p block, what happens, they belongs to the group 13 to group 18, and outermost electronic configuration in case of p block is ns2 np1 to 6, and generally helium is having the 1s2 is s block element, but it is positioned with the group 18 elements, right? Initially, so helium having the electronic configuration which is similar to the s block, so but it is positioned in the group 18. Remember, this is one exceptional cases. So helium having, even though it is having the 1s2 that is electronic configuration, it is positioned, or it means it is grouped under group 18 elements. So because it has completely filled valency shell, they may ask the question for your CAT also, why helium is grouped under group 18 elements or kept under group 18 elements, even if it has the electronic configuration which is similar to the group 2 or which is similar to the s block elements. The reason for this is because it has completely filled valence shell. It has completely filled, which means the orbitals are there is completely filled electronic configuration. So therefore in case of valence shell, and it results in the exhibit the characteristics of the noble gas due to the completely filled valence shell, and it results in the same characters which are shown by the noble gases. The same character is shown by the helium element, so therefore it is grouped under the group 18, or it is grouped under the noble gases, right? So this one is exceptional cases. Other than this, so all the p block elements are having the electronic configuration of ns2 to np6. Okay, further if you go for the third one, that is d block elements, there is another name for the d block elements, and these are generally called as the transition elements, right? So these are present from group 3 to group 12. The elements which are present from group 3 to group 12 are generally termed as the d block elements, and these are generally called as transition elements, right? So the general outermost electronic configuration The general outermost electronic configuration for D block elements is given as n minus 1 d1 to 10, and it is ns1 to 2. Sorry, here I have made a mistake. So this is not nd1 to 10, this is n minus 1, so d1 to 10, right? So this is n minus 1 d1 to 10. So therefore the outermost electronic configuration here is n minus 1 d1 to 10, that is ns1 to 2, and it is np 1 to 6, right? So you must consider both S and P along with D whenever you are writing the electronic configuration of D block elements, or you can also call them as a transition elements, right? So there is another name for D block elements which is known as transition elements, and these are present from group 3 to group 12, and the general outermost electronic configuration, that is NS2, NP6, and N-1 D1 to 10, N-1 D1 to 10. The four transition series are 3D, 4D, 5D, and 6D. Right? So there are four transition series in case of D block elements, that is a 3D, 4D, 5D, and 6D. These are the very important transition series in case of D block elements, and the 6D series is incomplete. Remember, always remember. So the 6D series, the last series in case of D block elements, is incomplete. So it is not complete. So therefore it is generally called as incomplete, right? So this is the general information regarding to the D block. And the last block which is kept separate from the periodic table, that is called as F block elements, and these are inner transition elements. These are generally called as inner transition elements, and the general electronic configuration of the inner transition elements is given as that is n minus 2 f1 to 14. F is the F block, and maximum it can hold 14 electron, because there are 7 orbitals in case of the F block, so different orbital. So therefore further you have to write for the D, S as well as P also. Therefore it is n minus 2 f1 to 14, n minus 1 d1 to 10, and it is ns2. And they are divided into two groups. One is the lanthanoids and another one is actinoids, right? So generally there is another name for F block elements, that is called as inner transition elements. D block elements are called as transition elements, and F block elements are called as inner transition elements, right? So here I will draw some rough diagrammatic representation of the periodic table, right? So which means there are group 1 to group 18, right? So in the periodic table consists of group 1 to group 18. So if you see the diagrammatic representation of a periodic table, so it looks like this. Right? So this is some of the rough work. So you can observe here, right? So like this, the groups are present, right? So these are 18, right? So these are total 18, right? So here what happens? So group 1 and group 2, right? So generally group 1 and 2 so are generally formed as S block elements, right? And group 3 to, right? So here group 3 to group 15, sorry. So group 3 to group 13 to group 18, right? So the elements which are present from group 13 to group 18, that is group 13 to 18, are generally called as P block, right? So S block is nothing but group 1 to group 2, and group 13 to group 18 are generally called as P block, and in between, right? So in between, the elements which are present in case of group 3 to group 12, this is group 3 to group 12, these are considered as D block elements. These are considered as a D block element. And last one is, so this is a F block. This is F block, and it is called as a lanthanoids, and it is called as actinoids, right? So this is the clear representation of the periodic table in the rough work. Here you can observe, so the group 1 and group 2, right? So these elements, group 1 and group 2, are generally considered as the S block elements, right? And group 13 to group 18 are generally considered as the P block elements, right? So this group 12 to group 13 are considered as the P block elements, and in case of here in group 3 to group 12 are considered as the D block elements, and the F block elements are consist of two groups, that is the lanthanoids and actinoids, right? So this is the simple representation regarding to the periodic table, which are divided into four different groups. One is S block, second one is P block, middle one is so D block. Since it is present in between S and P, so it is called as, it is a transition element, right? So it is called as transition elements, right? And there is another name for F block element. Those are called as inner transition elements, right? So inner transition elements, always remember the another name for, right? So since they are transist between S and P, so these are generally called as the transition elements. And the F block elements which are kept away from the, or kept a certain distance from the periodic table, that is 3 different groups, that is group 1, there is S block, P block as well as D block. So therefore it is termed as the F block element. And another name for F block is inner transition element. Here the most important thing is you must know the electronic configuration. So for S block, already we have seen, for S block the electronic configuration is NS2, and for that is 1 to 2, minimum is 1, maximum is 2, right? So for P block, the outermost electronic configuration is NS2, NP 1 to 6, minimum is 1, maximum it can hold 6 electrons. For D block, the electronic configuration becomes NS2, so NP6, so that is N minus 1 D 1 to 10, that is N minus 1 D, minimum 1, maximum it can hold 10 electrons. So similarly for F block, so you must write all the electronic configuration NS2, NP6, so N minus 1, so D 1 to 10, and it is N minus 2, so F 1 to 14, right? So maximum it can hold the 14 electrons. Here you can observe, so minimum is 1, maximum is 2, right? So in case of P block, minimum is 1, maximum is 6. So in case of D block, it is minimum is 1, maximum is 10. And in case of F block, so maximum it can hold 14 electrons, right? So these are the general electronic configuration, right? So these are considered as the general, right? So general electronic configuration in case of different groups, that in different blocks in the periodic table, S block, P block, D block as well as the F block, right? So this is the complete information regarding to the different blocks which are present in the periodic table. First one is S block, second one is P block, third one is D block, and fourth one is F block. Just you have to remember the groups which are present in S block. S block consists of 2 groups, group 1 and group 2, and these are called as alkali and alkaline earth metal respectively. And the electronic configuration in the outermost orbit is that is the NS1, and maximum it can hold 2 electrons, so it is called as NS2. So in case of P block, these belongs to the group 13 to group 18 in the periodic table, and the NS2, NP 1 to 6. And in D block, these are generally called as transition elements, and they consist from the elements from group 3 to group 12. The general outermost electronic configuration is N-1, D 1 to 10, NS 1 to 2. You can also write for the P, that is NP 1 to 6. And in case of F block, the another name for F block is inner transition elements, and you know the electronic configuration, that is N-2, F 1 to 14, maximum it can hold 14 electrons. And you can also write for D as well as F, D as well as P as well as S also. And they are divided into 2 groups. One is lanthanoids and actinoids, and these are kept away or certain distance from the main groups like P block, S block as well as D block. And most important 1 mark question in this is, the S and P block elements are generally called as main group elements, and there is another name for that, is called as representative elements. And there is another class of elements in the periodic table. These are generally called as noble gases, right? So the gaseous elements of group 18, generally the last group which is present in the periodic table, we'll call it as group 18, right? So this group 18, right, so the last group which is present in the periodic table, so these are called as noble gases. Generally these are termed as noble gases. So because they will not react with any of the molecules or any of the substances in the universe, because it is completely filled electronic configuration and they are more stable. Since there is a completely filled electronic configuration, they will not react, or there will be no any kind of exchange of electron in case of noble gases. Therefore the gaseous elements of group 18 are generally called as noble gases, right? So the group 18 elements are called as noble gases. And the general outermost electronic configuration of group 18, except helium, other than helium, because helium having the electronic configuration similar to the S block, but the characteristics of completely filled electronic configuration resembles, and it is grouped under the group 18 elements, there is noble gases. But the general outermost electronic configuration of group 18, except the helium, is NS2 NP6. It is NS2 NP6, and it has the outermost electronic configuration, that is helium, that is 1s2. The only helium has the outermost electronic configuration of 1s2, but other than helium, all the elements of the group 18 are having the electronic configuration of NS2 NP6. The general outermost electronic configuration is ns2 np6, right? So thus the outermost shell of the noble gas is completely filled, right? So the most important thing here is, so the outermost shell of the noble gas, so whatever might be the noble gas, so you take, so that is group 18 elements other than helium, it is completely filled electrons. The outermost orbital is generally consist of all the filled electronic configuration in case of its outermost shell, right? So that is the main thing in the periodic table. So other than all the F, D, P as well as S block elements, there is one more group which is generally called as noble gases, and these elements are group 18. Generally, the gaseous elements of group 18 are called as noble gases, and outermost electronic configuration for this group 18 is ns2 np6, and helium. The one exceptional case is helium has the electronic configuration of 1s2, and thus the outermost shell of the noble gases is generally completely filled electronic configuration, and this will not react with most of the substances, or many substances will not react with these molecules since they consist of completely filled electronic configuration. So further, if you go for the definition of periodicity, what is periodicity? So periodicity is nothing but the repetition of similar properties after the regular intervals is called as periodicity, right? So this can be asked for 1 mark. Define periodicity. Periodicity means, so whenever you arrange, right? So like this, whenever you arrange the elements in an different periods, you'll get the same characteristics, right? Or same properties can be observed, right? So whenever the elements are arranged in the form of periods, so there the repetition of similar properties, which means that the two elements might have the same the properties like physical properties or chemical properties after a regular interval, which means in between there are elements, but when it is repeated from one element to the another element, so then during that repetition what happens, there is a chance of having the same characteristics or the same properties, and that property is generally called as periodicity. That is the general arrangement of elements, so that is generally called as periodicity. And main cause, what is the reason for the periodicity, why the same characteristics or same properties are carried through different elements, right? So that is, the properties of elements are the periodic repetitions of similar electronic configuration of the elements as the atomic number increases. The main reason for this is, whenever it is having the similar electronic configuration of the element, right? So the repetition, the periodic repetition, the continuous repetition of the similar electronic configuration of elements as the atomic number increases. Whenever there is an increase in the atomic number, so there are some elements which are having the properties which are same, the characteristics, so that is generally called as a periodicity in case of periodic table. So if you go for further different atomic properties, right, if you consider any of the atom, so atom consists of a nucleus, and the electrons will revolve around the nucleus, as you already know that one, and there are further atomic properties which can be observed in case of atoms or in case of elements, and these are the physical characteristics of the atom in an element are generally called as atomic properties, right? So the physical characteristics or physical properties in case of atom or in case of element are generally termed as atomic properties, and the properties such as atomic radius, ionic radius, ionization energy, electronegativity, electron affinity are generally called as atomic properties, right? So the different atomic properties in case of the element or in case of atoms are, so the properties which shows the physical characteristics are generally termed as atomic properties, and these atomic properties are classified as atomic radius, ionic radius, ionization energy, electronegativity, electron affinity, and these are generally called as atomic properties, which means we can explain the overall explanation regarding to the any atom if you know all these properties. One is atomic radius, one is ionic radius, third one is ionization energy, fourth one electronegativity, and fifth one is electron affinity, right? So further we can see the definition of these atomic properties, right? So if you go for the atomic radius, so in case of atomic radius, what happens, the distance from the center of the nucleus to the outermost shell of the electron in an atom or in an element is generally called as atomic radius, right? So here if you consider, we'll go with some amount of rough work here. So the atomic radius is nothing but, so here if you consider this is the nucleus, and the electron will revolve around the nucleus, so and it has a particular orbital arrangement, right? So here the electron is moving, Right? So the electrons are present in different orbitals. So here the distance between the center, that is center of the nucleus, and towards the last orbit. So this is called as atomic radius. Right, so in case of atom, right, so if you consider this as an atom, right, so in this atom what happens, the distance between the center of the nucleus and the last orbit, right, so the last orbit is generally called as atomic radius. Here you can observe the definition: the distance from the center of the nucleus and outermost shell, there is a last orbit. Outermost shell is nothing but the last orbit, and that of the electron, in which the electron is present in an atom of an element, is called as atomic radius, right? So they can ask for 1 mark. Define atomic radius. Atomic radius is nothing but the distance from the center of the nucleus to the outermost shell of the electron, in the form of any element, right? So atom of any element is generally called as atomic radius, right? So, and how it changes in a periods as well as groups, right? So we know that the elements are arranged in the form of periods as well as groups. So in periods, the atomic radius of the element goes on decreases from left to right, right? So which means if you observe the periodic table here, so this is the representation of the periodic table. If you go from left to right, what happens? The atomic radius that goes on decreases, right? So that goes on decreases. But when you come from up to down, that means in case of groups, what happens? The atomic radius increases from moving top to bottom, right? So here if you observe, if you consider this as a periodic chart or periodic table, so if you go from left to right, what happens? The atomic radii, right? So atomic radius, it goes on decreases, right? So from left to right it goes on decreases, but from top to bottom, right, so from top to bottom it goes on increases. In case of periodic table consists of different elements, and here what happens? The main important thing here you have to observe is the atom which is having the atomic radius, that is nothing but the distance from the center of the nucleus to the last orbit, is generally called as atomic radius. And this atomic radius, when you observe in case of periodic table, whenever we go from left to right in the periodic table, so the value goes on decreases. But whenever we observe the atomic radius, we can observe in case of top to bottom in the periodic table, it goes on increases, right? So keep that in your mind. That can be asked for 1 mark. Define. So the question may be define atomic radii and how it varies in groups and periods, or how it, right? So how it can vary in the periodic table. They may ask for 1 mark, or they may ask for 2 marks, right? So therefore remember, the atomic radius is nothing but the distance from the center of the nucleus to the outermost shell. I have also shown the representation here. So whenever there is a distance, you measure the distance between the center of the nucleus and the last electron which is present in the last orbit, and this is called as atomic radius. And whenever you see the periodicity, that is atomic radius, so which can be observed in case of periodic table in different elements, whenever you go from left to right, if you go, what happens? The value goes on decreases. And similarly, the atomic radii, when you observe from top to bottom, what happens? So it will increase. There will be increase in the atomic radius. So therefore they may ask the question for your annual examination: define atomic radii and how it varies in case of groups and in case of periods in the periodic table. So once we'll see what we have learned in the today's class. The first important thing we have learned is the periodic table consists of different blocks. That is, it is divided into 4 different blocks. That is S block, P block, D block, and F block. Along with that, we have seen the general electronic configuration and different groups which are present in S, P, and Ds as well as F block. The another name for S and P block is generally called as representative elements, and the D blocks are called as transition elements. F block is called as inner transition elements, and grouped 18 elements are called as noble gases. That also we have seen. And along with that, we have seen the skeletal diagrammatic representation or the rough diagrammatic representation of the periodic table. So once you go through the NCERT textbook, in that there is a clear view or clear picture of the periodic table, which consists of 4 different groups. So that is it consists of 4 different blocks. One is S block, P block, D block, as well as the F block, which is kept away from the periodic table. Along with that, we have seen one important definition, that is periodicity and causes for the periodicity. Along with that, we have seen the atomic properties. There are different atomic properties like atomic radius, ionic radius, ionization energy, electronegativity, and electron affinity. In that, we have completed one important atomic property, that is atomic radius, which can be defined as the distance between the center of the nucleus and the last orbit which is present, and the electron which is present in the last orbit. And how it varies from group to group as well as period in the periodic table means, whenever if you go from left to right in the periodic table, the atomic radius decreases, and whenever you go from top to bottom, the atomic radius goes on increases. So that's all we have studied in the today's classes. So we'll continue in the next classes. Thanks for joining.